Hello students, today we will discuss 12th science chapter number 1 relation and functions, and in previous video we already discussed concepts of chapter number 1, and today we will discuss exercise 1.1. Question number 1, determine whether each of the following relations are reflexive, symmetric and transitive. We already knew the definition of reflexive, symmetric and transitive. A relation R in a set A is said to be an equivalence relation if R is reflexive, symmetric and transitive. Question number 1 is, first one, relation R in the set A equals to 1, 2, 3 up to 13, 14. Define as R equals to order pair x comma y, 3x minus y equals to 0. Means we have to take values of x and y, and we have to check this relation is reflexive, symmetric and transitive or not. First of all, we will define the relation R equals to, if we take x equals to 1, then we will get 3 ones are 3 minus y equals to 0. Then you can also write like this, x equals to 1, then 3 1 minus y equals to 0, it's y equals to 3, and we will get the order pair 1 comma 3. If we take x equals to 2, then we will get 3 2 is 6, then y equals to 6, and again second order pair is 2 comma 6. Third one is, if we take x equals to 3, then we will get 3 3s are 9, then y equals to 9, and we will get the order pair 3 comma 9. Same thing, if we take x equals to 4, then we will get 3 into 4 minus y equals to 0, there we will get y equals to 12, and the fourth order pair is 4 comma 12. We can't take x equals to 5, because if we take x equals to 5, then value of y is 15, is not belongs to A. That's why this is our relation defined, and now we have to check this is symmetric, transitive and reflexive. First of all, if first we will check for reflexive, 1 1 2 2 up to so on 14 does not belongs to R. That's why R is not reflexive. Means elements itself belongs to the relation, but here that is not belongs to in the relation. That's why R is not reflexive. Second, we will check for the transitiveness. If we take order pair 1 3 and 3 9 belongs to R, but 1 9 does not belongs to R. That's why R is not transitive. Third one is for symmetric, 1 comma 3 belongs to R, but 3 comma 1 does not belongs to R. That's why R is not symmetric. That's why this relation is not reflexive, not transitive and not symmetric. Question number 2, relation R in the set natural number defined as R equals to x comma y equals to x plus 5 and x less than 4. If we take values of x, we will get the order pair. If we take x equals to 1, we will get y equals to 1 plus 5 equals to 6. That's why relation R is defined 1 comma 6. Second one, if we take x equals to 2, Then we will get y equals to 2 plus 5 equals to 7. Then our second order pair is 2 comma 7. If we take x equals to 3, then we will get 5 plus 3 equals to 8. Then our third order pair is 3 comma 8. Then according to our condition, we can't take more than 3 because x less than 4. That's why this is relation defined. Now we will check for the first one, reflexive. First 1 comma 1 does not belongs to R, that's why R is not reflexive. Second, for symmetric, 1 6 belongs to R, but 6 1 does not belongs to R, that's why R is not symmetric. Next, for we will check for transitive, x y y z belongs to R. Now since there is no pair in R such that x y and y z belongs to R, so we need to look for the order pair x z belongs to R, that's why R is transitive. Next, question number 3, are in the set A equals to 1 2 3 4 5 6 as R x comma y colon y is divisible by x. Here first of all we will check y is divisible by x. First, for the reflexive, we know that any number x is divisible by itself, that's why x belongs to R, therefore R is reflexive. Now 2 comma 4 belongs to R as 4 is divisible by 2, but 4 comma 2 does not belongs to R because 2 is not divisible by 4. Therefore, R is not symmetric. Next, third property, its transitiveness. Let xy and yz belongs to R, then y is divisible by x and z is divisible by y. Therefore, z is divisible by x. This is the vice versa. Again, I will explain. Y is divisible by x and then z is divisible by y. Therefore, z is divisible by x. Therefore, R is transitive here. Therefore, in this question, R is reflexive and transitive but not symmetric. Next, in question number 4, R in the set of Z of all integers as R equals to x comma y, x minus y is as integers. First of all, we will check for the reflexiveness. For every x belongs to Z, there is x comma x belongs to R as x minus x equals to 0 is an integer. That's why R is reflexive. Now every for every x and y belongs to Z, if xy belongs to R, then x minus y is an integer. Therefore, it implies that minus x minus y is also an integer. It implies that y minus x is an integer. Therefore, y comma x belongs to R. That's why R is symmetric. Next, we will show for the transitiveness. Let x comma y and y comma z belongs to R, where x, y, z belongs to Z. It implies that x minus y and y minus z are integer. It implies that x minus z equals to x minus y plus y minus z. You can add them, x minus y plus y minus z. It will again give us an integer. It implies that it directly shows that x comma z belongs to R. Therefore, R is transitive. In this question, all the properties are satisfied. R is symmetric, reflexive, and transitive. That's why this relation is called an equivalence relation.